Assalamualaikum warahmatullahi wabarakatuh. My name is Salmahanim binti Sazali. I will present my review on a few articles that I have read related to analysis of drugs in blood samples using solid phase microextraction method. Drugs have been used as a remedy for treatment since 1800s. Since then, drugs have evolved to treat medical cases and as psychotherapy substances. Drugs is substance when ingested is capable of inducing a psychological change, and high intake of drugs can lead to mental health issues, include hallucination, aggression, anxiety, and other problems. Principle of extraction method. Solid phase microextraction or SPME is a sampling technique based on absorption. With SPME, the analytes are absorbed from the liquid or gaseous sample onto an absorbent coated fused silica fiber, which is part of the shrink needle for a fixed time. As you can see the structure of SPME device, the fiber is located inside the septum piercing needle. When the coated fiber is placed into an aqueous matrix for a predetermined time, the analyte is transferred from the matrix into the coating. The extraction is considered to be complete when the analyte has reached an equilibrium distribution between the matrix and fiber coating. After a sampling period during which extraction has ideally reached equilibrium, the absorbed solutes are transferred into an inlet system that dissolves the solutes into a gas for gas chromatography or liquid for liquid chromatography mobile phase. During desorption of the analytes, the fiber is clean and therefore ready for use. There are two types of SPME, which are direct immerse and headspace. In direct immerse SPME, the fiber is directly immersed or inserted in liquid samples. It works best for low concentration water-based sample matrices. As you can see in the picture, the position of the fiber just below the sample surface and maintain this position consistently for all extraction. For the headspace, the fiber is exposed in the vapor phase above a gaseous, liquid or solid sample. It is suitable for the analysis of volatile organic compounds. It is extremely important to keep the headspace volume constant and keep the fiber position at the same depth every time extraction. Sample collection and preparation. All samples were stored frozen until used at the temperature of -20 degrees Celsius. Since the samples were blood samples, it is stored at cold temperature because biological samples degrade easily in room temperature. Blood were prepared 24 hours prior to the analysis by spike tank with a known amount of internal standards, solutions, and drug solutions. Spike samples were stored at the temperature of 4 degrees Celsius until the extraction process. This is preparation for the direct immerse SPME. For the headspace, the blood samples were taken into a micro test tube. Added cholesterol oxidase solution likely vortex. The cholesterol oxidase solution were added to remove cholesterol because cholesterol can interfere the measurement of one of the synthetic cannabinoids in the samples. And then the samples was incubated at 37 degrees Celsius for 5 minutes. Then acetonitrate was added and vortex lightly for deproteinization, followed by centrifugation. The supernatant was collected as far as possible and transferred into an SPME vial. The liquid phase was purged to dryness gently under nitrogen stream at 50 degrees Celsius. The vial was then capped with 20 mm magnetic screw cap with silicone septum, followed by headspace SPME GCMS analysis. For the sample extraction method for direct immerse SPME, the fiber was conditioned in 1.5 ml of methanol solution to remove contaminants from the fiber. And then the fiber is directly immersed into the samples, which is blood samples, for the absorption of analytes to the fiber. And then after a period of time, the fiber was wiped with a dust-free tissue, then washed in the ultra-pure water with vortex agitation. This is to remove the residues of biological materials deposited on the fiber coating. And then the desorption was carried out with the use of desorption solution of acetone, methanol, and 0.1% formic acid. After that, the desorption solution were evaporated with the use of vacuum evaporator at temperature of 45 degrees Celsius. Afterwards, the mobile phase was added, washing in ultra-pure water and mechanical purification. And after the pre-concentration, the samples was analyzed using liquid chromatography, mass spectrometry. For the sample extraction for headspace, SPME, as you can see, the fiber is placed in the kept at the headspace of the vials, and during the extraction, the samples was heated to allow the analytes to evaporate and absorb onto the fiber. After a period of time, the fiber will be immediately injected into injector port of GCMS for the desorption and for the analysis of the samples. For the results, the direct immersed SPME, LC-TOFMS, time-of-flight mass spectrometry method can be used successfully for blood and bone marrow aspirate samples. The standard deviation of concentrations were determined for each sample, and it was less than 50%, which means the experiment is the data is accepted. And the validated SPME UPLC mass spectrometry method revealed excellent accuracy, repeatability, and selectivity. The analysis of immunosuppressive drugs from whole human blood using bio-SPME or IMS, which is microfluidic open interface mass spectrometry technology, was successful. The method reduced the yield time of the samples. All standard synthetic cannabinoids were successfully analyzed using Headspace SPME GCMS. The suggested method would be extremely useful in forensic sciences, particularly for the detection of synthetic cannabinoids in herbal combinations as well as blood samples. The advantages of SPME methods enables the extraction of small target molecules from biological matrices of interest, eliminates the need of protein precipitation, centrifugation, or any other sample preparation. It will minimize the sample preparation. This is for the advantage of direct immersed SPME method. And for the SPME device can be directly immersed into the samples without much concern about damage caused by fouling. The time of the whole analysis is shortened, and solvent-free and sensitive method for the extraction of analytes. And the SPME methods are low cost. Disadvantage of the method is limited number of available fibers and number of places in the shaking plates. Some level of degradation of the fiber occurs during repeated usage, and fibers are fragile and can break easily. That's all from me. Thank you.